Hi guys, welcome to Algebra 1. We are looking today at how can we apply some of this information that we've been learning. Not just the information we've been learning from Chapter 3 about functions and relations, but also looking all the way back to Chapter 2 in how we can write equations. All of this fits together in some really neat ways. So today we're going to look at one application, which is called sequences. So first thing we need to do is we need to define what a sequence is. So a sequence is simply just a list of numbers that follows a pattern. So we're going to fill that first word in with pattern. And sequences can follow all kinds of patterns, but what we're going to do is we're going to look for one specific type of sequence right now because it follows a linear pattern, and that sequence is called an arithmetic sequence. It's like the word arithmetic because it follows a specific type of sequence that follows a pattern of adding and subtracting. It needs to follow adding or subtracting the same number repeatedly. So we're not talking about like adding 2, then subtracting 6, and then adding 2 and subtracting 6. That is a pattern. It follows a sequence, but it's not the type of sequence we're looking for today. We're looking for specifically one that adds 2, adds 2, adds 2, or subtracts 7, subtracts 7, subtracts 7, subtracts 7. Now, once we found that type of sequence, an arithmetic sequence, it can be written using two different formulas or two different patterns, two different equations. And so we're going to look at both of those today and look at why would we use one over the other, or how is one helpful or more useful than the other. So the two patterns that we're going to be looking at are one called a recursive formula and one called an explicit formula. Now, those two words kind of give us a hint on what kind of rule they're going to be. Re is a prefix that talks about doing something over and over and over again, and that's what a recursive sequence does, or recursive formula. It tells you what you're doing and then asks you to do it repeatedly. So recursive formula is going to look like this. It's going to tell you now equals a number. That's going to tell you where the sequence begins. So the number that we're going to use is the first number in the sequence. And then it's going to say to get the next term, you're going to take the now term and add d. That d stands for the common difference, or the thing that we're doing over and over and over again. And so it will look something like this. It might say now is 4. And then it might say to find the next term, take the now term and add 2. So what that means is now equals 4. That tells me the first term in the sequence is 4. And then to find the next term, we're going to take the now, which is 4, plus 2. That gives me 6. Now again, to find the next term, we're going to take the now, which is now 6, and add 2 to get me 8. To find the next term, we're going to take the now, which is 8, and add 2, which gets me 10. And to find the next term, we're going to take the now, which is 10, and add 2, which gets me to 12. And the sequence would continue on and on and on like that. An explicit form, on the other hand, is more like a linear equation that we've been writing. So we can think about it in the terms of y equals mx plus b. And so to write this one, if you'll notice the d this time is right here. The d is still the common difference, but if you'll look at where that's placed in the slope position. So the difference, what we're doing over and over and over again, is actually the slope of our line. And that makes sense because the slope is how we're moving over and over and over again. And then b just stands for that y-intercept, or where we're beginning. And so the way that this one would look is something like this. It might say a sub n is equal to 2n plus 2. And so the way we would use this is we would say, okay, what if that n value is 1? In other words, what we're looking for is the a sub 1 term. That means the first term. And so we would plug 1 in. 2 times 1 is 2. Plus 2 more tells me that the first term is 4 in this sequence. If I want to find the second term, I'd let n equals 2, which is a sub 2. So that means take 2 times 2 plus 2. 2 times 2 is 4, plus 2 more is 6. Let's do one more. If I were to find the third term, a sub n, or n equals 3, that would be a sub 3. That means third term. I would take 2 times 3 plus 2. And 2 times 3 is 6, plus 2 more is 8. If you'll see, these are both giving us the same sequence, 4, 6, 8, and so on. They're just different ways of finding it. Now, let me give you just a little bit more background here. The reason that we say a sub n is a is telling us that this is an arithmetic sequence. So this is a way of writing sequences, a sub n. And then n is just like that x term, or what we would replace, what variable we would replace our number with for the term. So let's just review a little bit about these sequences. The way we write explicit sequences is using like a slope-intercept form. I'm going to show you how to do that here in just a minute. But we're going to start most of the time with explicit sequence. We're going to start it in point-slope form. So guys, that information that we learned last chapter doesn't go away. We're still going to be applying that in the next few units. Why is explicit form helpful? Explicit form is helpful if I need to find any term in the sequence. If I ask you to find the 100th term of the sequence, explicit form is the way to go. So again, pros, the pros for explicit form is we can find any term in one step. The cons, though, are the formula is a little bit tougher to write. You've got to think through some steps on this one. But once you have that formula written, it's pretty easy to use. Recursive, how do we write this form? This is the one that starts with the now equals a number, and then the next equals the now plus a number. It could also mean minus the number. Why is a recursive formula helpful? It is super easy to use and to write. So our pros are it's easy to use and easy to write. But our cons are if you have to find a term and it's a term that's not close to the beginning, you have to find every term before it. You must find every term before it. So if I ask you to find the 100th term, you have to know the 99th. And to know the 99th, you have to know the 98th. And to know the 98th, you have to know the 97th, all the way back to the beginning of the sequence. So today, you're going to be doing an assignment, and we're just going to do kind of a mini assignment to kind of show you how this works. On this assignment, sometimes I'm going to give you a sequence, and I'm going to ask you to write the different forms. Sometimes I'm going to give you one of those forms and ask you to write the sequence or other forms from that. And so we're just going to practice through these 3 examples. And then from here, I'm going to give some more examples. If you feel like you're comfortable with this, you may skip the rest of the examples after this sheet and get to work on your homework. If you're still a little confused, then I would invite you to stick around for a few more of those examples. All right, so in this case, the first thing they ask is, or they give me is a sequence. So before I even begin, before I can write a recursive or an explicit form, I have to determine, is this an arithmetic? Is this following a pattern of adding the same numbers over and over or subtracting the same numbers? So I'm just going to test it by saying 5 to 11. If I'm not sure, I can take 11 minus 5, and I find out what I'm doing is I'm adding 6. And then 11 to 17, I'm also adding 6. And then 17 to 23, I'm also adding 6. So I can feel pretty confident, since I've done the same thing over and over, that this is an arithmetic sequence. So if so, I'm ready to write my recursive form. My recursive form starts with now equals. And remember, that's our first term. So in this case, what would our first now equals be? I hope you said 5, because that's where we begin this sequence. The next part, we say now to get the next, we're going to take the now, and what are we going to do repeatedly over and over and over, because recursive is that repeated process. That's right, we're adding 6 over and over and over. That's all there is to writing the recursive form of this problem. I told you explicit is a little bit harder to write, but we can still use explicit form, and we can use our knowledge of point slope. And so to do that, what I'm going to do is I'm going to look at this first term, and I'm going to write a point of 1, 5. What that means is 1 is the first term of the sequence, and 5 is the number that actually is. You've already found the slope by finding that repeated addition over and over. So in this case, the m is 6. Guys, once I know a point and a slope, I can use my point slope form to write my equation. So I'm going to start by saying y minus 5 is equal to 6 times x minus 1. But remember, we want this form to look like that slope-intercept. So I'm going to do the 2 extra steps, which means I'm going to distribute and get 6x minus 6. Still have that y minus 5 on this side. And then I'm going to add 5 to each side. And I'm going to end up with an equation of y is equal to 6x minus 1. Now, just to put this back into sequence form, I'm just going to come over here to the side, and I'm going to replace the y with a sub n. That just means I'm talking about an arithmetic sequence. A sub n is equal to 6, and then I'm going to replace the x with an n minus 1. So there is my explicit form. Now, finally, on this column, it says find a sub 9. Well, a sub 9 means the 9th term of the sequence. So I have 2 options here because I have 2 forms written. I can start with my recursive form and say 5, 11, 17, 23, and then just keep adding 6 until I get out to 9 terms. Or in one step, I can say a sub 9 is equal to 6 times 9 minus 1. 6 times 9 is 54. 54 minus 1 is 53. So I can feel confident that the 9th term of the sequence would be 53. If you're not sure, go ahead and add it out. Keep adding 6, adding 6, adding 6 until you get to that 9th term. I think you'll find that that's the same one. All right, second one. What if I give you the recursive form and I ask you to write an explicit and find those different terms, but I also ask you to find the sequence? Guys, I think these are always easiest if we start by figuring out what the sequence is so we can see what it looks like. So writing the sequence, this first says now is 10. That means my first term is 10. To find the next term, it says take the now and subtract 3. So 10 minus 3 would give me 7. Then take the new now, 7, and subtract 3. That would give me 4. 4 minus 3 would give me 1, and so on. All right, so now I have a picture of what my sequence looks like. If you'll remember, we were subtracting 3 each time, so that tells me what my slope is, or my common difference is, and my first term of my sequence is 10. So that gives me the 2 pieces of information I need to write my equation. The first point is 110, and the slope is negative 3. Now, there's nothing magical about the point that I'm using. I could use 2, 7 or 3, 4. I just think it's easiest to start with the first one. So point slope form says y minus 10 is equal to the slope negative 3 times x minus 1. Since I want it in slope-intercept form, I'm going to go ahead and distribute and get y minus 10 is equal to negative 3x. Remember, plus 3, because that negative 3 times negative 1 gets me a positive. And then I'm going to add 10 to the other side. All right, in this case, I get y is equal to negative 3x plus 13. Again, if I want to write that as a sequence, I'd say a sub n is equal to negative 3n plus 3. There's my arithmetic sequence. Oh, I should not say 3 plus 13. I said 13, but didn't write 13. All right, at that point, guys, now I'm ready to find a sub n. Again, I can use the recursive form if I want and just keep subtracting 3 until I get to the 9th term. Or I can say a sub 9 is equal to negative 3 times 9, because I'm looking for the 9th term, plus 13. Negative 3 times 9 is negative 27, and negative 27 plus 13 gives me an answer of negative 14. So the 9th term would be negative 14. All right, last but not least, what if I give you the explicit form and I ask you to find the rest of this information? Just like before, I think it's always easiest to start by finding your sequence. And so what we're going to be doing is we're going to be looking for a sub 1, a sub 2, a sub 3, and a sub 4. In other words, we're going to replace the n value with a 1, 2, 3, and 4. So with a 1, it would be 3 times 1 plus 8. 2 would be 3 times 2 plus 8. 3 would be 3 times 3 plus 8. And 4 would be 3 times 4 plus 8. Then this is just arithmetic. So 3 times 1 is 3 plus 8 gives me a value of 11 as my first term. 3 times 2 is 6 plus 8 gives me a value of 14. 3 times 3 is 9 plus 8 gives me a value of 17. And then 3 times 4 is 12 plus 8 gives me a value of 20. So in this case, I'm adding 3 each time over and over and over again. And so that I know this is arithmetic, that matches my slope, so I feel confident with all of those things. So I start with the now, and remember the now is the first term, so 11. And the only way I know that is by actually writing the sequence and then going to my next and saying that's now plus that common difference. All right, we already have the explicit form written. That's the one that takes up time, so we're ready to go straight to finding a sub 9. So in this case, that would be 3 times 9 plus 8. 3 times 9 is 27. 27 plus 8 is 35. So the 9th term of the sequence is 35. All right, if you're feeling comfortable with this, you can go ahead and get that worksheet out and begin working through that. But if you've got questions, let me know and I'll be happy to help answer. All right, guys, we're going to go and just take a look at this second sheet here, just to give us some more ideas on what's going on in this, just some extra examples. So if we look at 1, it says determine if the sequence is arithmetic. So we're looking, can we have a common difference over and over and over again? So we look at this from 77 to 73 to 69 to 65. 61. Yes, we do have a common difference there. We're doing the same thing over and over and over again. What are we doing? That's right, we're subtracting 4. So in this case, if we were writing a recursive form, we'd start with the now equals 77, and the next is now minus 4. If you worked with the explicit form, this one should end up being y, or a sub n, is equal to negative 4n plus 81. Number 2, it says determine if the sequence is arithmetic, if it has a common addition or subtraction, and if so, write the explicit form and the recursive form. So when I look at this one, from 1 to negative 2, I'd be subtracting 3. But then from negative 2 to 3, I'd be adding 5. Right there, I can stop and say this is not an arithmetic sequence, and so I can stop. I don't need to write an explicit formula or a recursive formula because it doesn't fit either one of those. Number 3 says write the first 5 terms of the sequence based on this rule. Guys, they give you the first one. The now is 8, so that's the first term. And then what are we doing over and over and over again? That's right, we're adding 15. So 8 would be my first term. Then 8 plus 15 would give me 23. Then 23 plus 15 would give me 38. 38 plus 15 would give me 53. And then 53 plus 15 would give me 68. There are my first 5 terms. Number 4, write a sequence based on this rule. This isn't an explicit rule, so we're going to plug in 1 for n and figure out what the number is. So 12 times 1 is 12. 12 minus 29 is negative 17. And so negative 17 would be the first term of my sequence. If I plugged in 2 to find the second term, I'd take 12 times 2, which is 24, and then 24 minus 29 gives me an answer of negative 5. So negative 5 is my second term. So I've got negative 17 and negative 5. Let's try one more, the third term. So we're plugging in 3 for n. So 12 times 3 is 36, and 36 minus 29 is 7. And so my third term would be 7. So my first 3 terms would be negative 17, negative 5, and then 7. At this point, if you see that what our pattern is that we're adding 12, we can just continue the sequence adding 12 each time. So then I'd have 19 and 31. Guys, if you've got questions, please let me know. Mr. Jordan is available in the mornings, and Mrs. Sanders is available around 11 o'clock most mornings. And so just send us an email, and we'll set up an appointment to talk with you about this. Again, don't let yourself get behind, because that's when it starts to feel overwhelming. So you've got several days. Try it out on the first day, and then get with one of us if you've got some questions. I hope you're having a great day, and if there's anything we can do to help, let us know. Thanks a lot, guys. Bye.